Let's look at how to use the Pythagorean theorem. Here I have two triangles. This is an obtuse triangle, but this one is a right triangle because the angle here is marked to show you that it's 90 degrees. That's the type of triangle that you can use Pythagorean theorem on. So I'm going to get rid of this one. Right triangle again. All of the sides can be called legs. However, the side opposite this angle, it's the longest side, and so it has a special name. We call it the hypotenuse. And we'll just call the other two legs. And so the Pythagorean theorem states that the sum of the two legs, each one squared, oops, let's write that here. There we go. So there's the sum. Those two things equal the hypotenuse squared. So please notice that you have the legs together on one side of the equal sign and the hypotenuse all by itself. The two shorter sides over here and the longest side by itself over here. Also notice that each term has to be squared. It won't work if you don't square them. All right, let's try it out. Let's suppose that you're given two of these, let's say 3 and 4, and you have to solve for the hypotenuse. All you do is you plug in the lengths into the formula. So we know that it's 3 squared is one of the legs, 4 is the other leg, and you're going to square that one, and the hypotenuse is what you're solving for. Now you can use a squared plus b squared equals c squared if you want. It doesn't really matter. This is the idea, right? You're solving for the hypotenuse. Whatever variable you want to use here is fine. What's important about working this out is remembering the order of operations. You need to square this first before you go adding. You can't really do that yet, right? 4 squared, which is 4 times 4. This side, there's nothing we can do, so we're just going to bring that down. 9 plus 16, we can bring that together, rewriting the equation. Now we're getting really close to our solution here. I'm going to need a little space, so let me try putting it up here. So what I'm going to do is take this line, it up here. So 25 squared equals, 25 equals h squared. What do I do with that? Well, remember your goal is to solve for h. You're trying to get to this. So this is really close, but we've got this squared here. What can we do? Algebra tells us that we have to undo it. We have to do the opposite. And it turns out that the opposite of a square is a square root. Let me show you what I mean. This radical symbol. They cancel one another out. And you're allowed to do that if you remember to do that to the other side, because what you do to one side of an equation, you must do to the other. And so now we continue to solve or work this out, evaluate it. We have h by itself, and over here, the square root of 25 is 5. So we can solve the question. Now, some people, when they get a different equation or a different triangle here, for example, let's suppose you're given the hypotenuse and you're given one leg and you have to solve for the other leg. And some people get a little concerned about what to do when they're given the hypotenuse. But let me show you you're really using the same formula, and so the steps are going to be similar. You're going to use a little bit of logic, some algebra, and it will take you to the answer. That's what's nice about the Pythagorean theorem. It helps you to solve right triangles. And when I say solve the triangle, that means find any missing sides. So what you would do is plug in the information into the formula. Well, this time, one of the legs, you don't know what it is. Let me stay with the same color so it's easier to see here. We don't know what it is, but we plug it in, and we still have to remember to square it. At least we write the square, even if we can't do any math. Plug this leg in, and this time the hypotenuse. All right, let's do some algebra and see what happens. Well, I can't do anything with this. 5 squared we can simplify. 13 squared, which is 13 times 13. We have a pretty basic equation. Let's go ahead and subtract 25 from this side. I'm running out of space here. But 25 minus 25 is 0, so that's going to go away. And then subtracting it from this side. Let me bring the results again up here. So I have x squared still equals 169 minus 25. Well, we're trying to get x by itself, so we're going to take the square root of both sides of the equation. That allows these to cancel. The square cancels with the square root. You have your goal here, x, and on the right-hand side, the square root of 144 is 12. So this leg must be 12. And that's how you use the Pythagorean theorem.